Hey guys, here's my review of the last homework assignment we had from class on a couple weeks ago, Friday. So this is solving systems of equations by substitution, right, including the special cases. So problem number one, substitute a little bit different here, substituting in x instead of y, right? Most of the problems we had before had y by itself, but in this one, there's x by itself right there, and we're going to substitute that into the first equation, right? So this 3y minus 7, we substitute into the first equation because it's the same as x. Then you solve combined like terms and two-step equation. You get your y answer, y equals 1. Substitute that in for y using equation, what I labeled number 1 here, the bottom one. That gives you your second variable, x equals -4. Substitute those x and y values right there in for x and y in the other equation, the one you didn't use, number 2, to make sure that that comes out to be true. And your answer then written as an ordered pair, -4, 1. Sorry if I'm blocking the web camera here. All right, number 2. Substitute in -2/3 x plus 4 in for y using parentheses like you see right here, okay? Because it's 3 times y in the second equation, so it's 3 times the whole thing, -2x plus 4, which is equal to y. Distributive property, that's your rainbow right here, right, which gives you -2x plus 12. 3 times -2/3 x, right? The cross canceling there, these 3's cancel each other out and you get -2. Then 2x plus -2x right there, that is going to equal 0. No x's, and the variable has dropped out. And what you're left with is 12 equals -6, which is not true. This is the no solution situation, right? If you had graphed these two lines, well, they have negative slope, so at least I should. You graph these two lines, they would look like that. No solution. All right, next one. Number 3, substitute -2x minus 1 in for y in the first equation, distributive property, combine like terms, solve the two-step equation, you get -2x equals 0 at this point right here, and that means that x equals 0. Substitute that in to find y using equation 2, and y equals -1. Do your check over here, and the answer is 0, -1, written as an ordered pair. Number 4. The second equation is solve for y, so I can substitute here this to -2/3 x plus 8. I substitute into the first equation instead of y, like that. That's how substitution works, right? Then we do the rainbow distributive property. You get -4x, 6 times -2/3. Right? Again, you fraction challenged people here. You multiply these fractions like this, and you cross cancel like this is a 1, and this is a 2, and that equals -4. Okay? You can do that work off to the side if you need to. 4x plus -4x, that's 0. So the x's are gone, and that means you're left with 48 equals 48. If you didn't do a good distributive property here, you might think the answer to this one was no solution, but it is infinitely many solutions. Number 5, big numbers here, but still the same process, right? Same way we solve all of these. You find one variable that you can substitute, so y and -x plus 50 are equal to each other. So in the second equation, instead of y, I substitute in -x plus 50 with parentheses, distributive property, combine like terms, -2x plus x here is equal to -1x. And then solve this two-step equation. Subtract 100 from both sides, then divide both sides by -1 because the opposite of x equals 100, so x equals -100. There's going to be a problem here for some people. When you put this -100, this x answer, that first equation, then you get the opposite of -100. So you got to be careful with that. All right, we'll finish this one up here. So since you substituted -100, your y there is positive 150. And then you can do your check over here, putting in your x and y values into equation 2. and they come out to be the same on both sides. So your answer is negative 100, comma 150. Number 6, substitute 2x plus 5 in for y. Watch out for that minus sign in the front there. That's really a plus negative 1 distributed to 2x and 5. All right, so 2x plus negative 2x and then minus 5. It doesn't really matter if you mess that up. You're going to end up with the variables dropping out because 2x minus 2x is 0 and negative 5 does not equal 3. It's not true. So that answer is no solution. Okay, then we get to a review here of a couple of graph problems like from a week ago, now 2 weeks ago. All right, so solve by graphing means that the equations must be in y equals mx plus b form, right? And so the first one is okay, but the second one is not. So you have to transform this equation. We have to get the y by itself. So first we subtract off this 2x from both sides to get rid of that, undo that addition. You can't combine negative 2x and negative 6. Those are unlike terms, so that's how you end up with negative 2x minus 6 on this side. The other side now still has a minus a 3y there, sorry. Now to get y by itself, divide everything by 3. So 3 divided by 3 gives you 1. Negative 2 divided by 3, negative 2/3. It's a slope, so fraction is okay for that. And then minus 6 divided by 3 is negative 2. So y equals negative 2/3 x minus 2. You might recognize right away here that these two equations have the same slope, negative 2/3. That means when you graph them, the lines are going to be parallel, and that means there is no solution. First line, negative 2/3 x plus 4. You start at 4 and go down 2 over 3, and then go from there down 2 over 3, and draw in your line. The second equation, which we've transformed to slope-intercept, starts at y equals negative 2, and also goes down 2 and over 3, and down 2 and over 3, and so there's your graph lines there. If you're told to solve by graphing, you have to graph both lines, even though from the equations you can tell that there's no solution. Okay, is 9, negative 2 a solution to none, one, or both of these equations? Well, the point 9, negative 2 is right here. I've graphed it for you, and it is on this line. So if it's on a line, then it is a solution. It makes that equation true. It is not on the other line, so that means that it is only a solution to the first equation. If you wanted to do this algebraically, then you could check it in both equations. That's what I've done down here. Okay, this is the alternate method for seeing if it's a solution. You substitute in 9 for x and negative 2 for y. Sorry about the typo right over there. And see if both equations come out, if it comes out to be true. One of them does, the other one does not. So it is a solution to one of these equations, but not both. So it is not a solution to the system. The system has no solution. And the last one, these two lines intersect. They intersect at the y-intercept here, which is 0, negative 1. They both have the same y-intercept, you see right there, but their slopes are different, so they are going to be intersecting lines. They intersect right there at the y-intercept, 0, negative 1. That's your solution. And you check that by plugging in 0 for x and negative 1 for y in both of the original equations. And that's the homework assignment. That reviews everything that we've done in this unit up to this point. And we'll see where we go from here.